So it's lesson 10, part 2. We've made a list of the unit tests that we're going to need. I'm going to hope my screen doesn't flicker now that I've downgraded my driver. Few people that are using Visual Studio Community tried to install this Avo cover extension. It's called Open Cover. I'll have to play around with it. It does seem to give some code coverage. So you can download this through tools and extensions. I'll maybe have a look at it. I might want to use it next week if it looks better than what's actually built into Visual Studio. It does seem to show code coverage. So let's start with our index method, probably the simplest. So first of all, let's maybe just start and check that this method loads a method called, loads a view called index. Let's start there. So in our unit test project, under controllers, we're going to add a new item. So we could go to test, and we could pick any of these. So yeah, I'll just pick basic unit test, and I'm going to call it albums controller test. So the convention is test class should have the exact same name as the controller it's testing with the word test on the end of it. So we have a home controller and a home controller test. We've got an albums controller. We'll have an albums controller test. So by picking that, it automatically gives me a reference to the unit testing namespace, which we know we're going to need. Now, right now, we have no access to our albums controller, so we need to reference our web project controller's namespace. It automatically gives it the test class annotation, and it creates a first test method. So we're going to rename this. And usually our test names should include both the name of the method they're testing, as well as a description of what we're actually testing. So what do we want to test in this case? What would be a good name for our test method? If we just want to check that our index method in albums loads the correct view. Yeah, okay. Well, sure. Typically, we start with the method name by convention. That would be wrong one. So we'll say index. Sure, we could call it index returns view. Maybe. That's what we're expecting. We're including the method we're calling and the behavior we're checking. So to arrange this, we can just instantiate an instance of our controller first. So we want to call the index method and return a view result. In this class, view result is not recognized. It doesn't know what that means. So we can just use Visual Studio's little code hint here. And it prompts us just make a reference to system.web.mvc. So notice right now at the top, the only reference is to unit testing in our controllers. So if we just accept that suggestion and reference the system.web.mbc namespace, our error goes away. Now we want to do our assert. Now we could assert that our result object is not null. That's probably not the best unit test. It would work, but why do we want to do more than just check that our result isn't null? Right, because we want to make sure not only that it returns a view, but it returns the view called index. So we want to assert that what we expect, you can see our parameters, we expect index and we'll try this. We can check it against the view.view name. So this is better than just checking that the result isn't null. Right? If it returns a view called create, well, it should throw an error. The test shouldn't pass. So we're expecting that the view name is going to be index. So let's run this test, see what happens. We'll build. And in my albums controller, I want to run our index returns view test. And our test fails. Why did it fail? What's that error message telling us? So when we run the test from here, it tries to connect to our database and fails because we don't have a database connection in this project. So let's go and look at our albums controller for a minute. Some stuff up that we don't need. So if we have a look at our albums controller, notice the first thing that happens when we create our albums controller. First thing it does that the scaffolding does is connect to the database. But we don't want it to connect to the database in this instance. We just want to call the index method. Problem is our index method is also using this database connection. So this is where we're going to have to refactor some of the code, and this is where our mock data comes in. So until we can solve this problem, our unit test is never going to pass. So what is this going to look like? Oh, I have it here. As you know by now, I am not the world's biggest PowerPoint fan, but in this case, it may be necessary. Kind of give you a visual of what we have and what we need, and this is really borrowed from this video. So we need some way to divorce our method so that it doesn't automatically use the database connection. Come on. I mean, one way, well, we'll maybe try from here. So we're going to need to refactor this so that our controller doesn't try to connect to the database as soon as we instantiate it every time. When our application is running in a browser, yes, we want it to connect to the database, but when we're unit testing, we don't want that connection to happen. We want to use mock in-memory data instead. So our controller needs to behave in two different ways. One when it's actually in production, and one when we're doing unit testing. Wildly annoying. You know you're not running. All right, we'll try one more time. All right, it's only 5 slides, folks. So this is what we've got right now. Again, these slides, I've kind of taken screenshots from the video. I take no credit for creating these slides. So here's what happens. As soon as we instantiate any scaffolded controller, it uses our database context, which uses Entity Framework, which connects through to our database. That happens automatically when we scaffold based on a model. So this works great when our app's running in the browser. Problem is this doesn't work with unit testing. So what we need instead is we need an interface that sits in between our controller and the database. So instead of the database being called directly here, we want to add an interface that when we're running live, will call the database connection for us. We're kind of introducing an intermediary here. So this is what it looks like when it runs in the browser. But when we're unit testing, we want a separate interface that just uses mock data instead. We've basically cut kind of 2 different workflows. One when our app is running and one when our app is being unit tested. So this will allow us to fake the database without connecting to it. So it basically will have 2 separate paths. When we're unit testing, our controller will use a fake repository that calls on some mock data. When our app is running live, it's going to follow this path, use our database class and Entity Framework, and go and work with the real data. So our app can dynamically work in one way or the other. So we're going to use, write this down, this will be on next week's quiz. Most important term of this week's class. We're going to use a technique called dependency injection. Anybody heard of a dependency injection before? This isn't a .NET thing. It's used in all kinds of different programming frameworks. What is it? How does it work? What does it mean? Right. Okay. So what dependency injection means is one object will receive another object, and depending on what it comes in, it will behave differently. And this happens at runtime as an application is executing. So in this case, here's how we're going to use dependency injection. When our controller receives in a mock object, it's going to take this path. It's going to check, hey, did I get a bunch of mock data handed to me when I was instantiated? If so, I'm just going to work with that mock data. If nothing is handed to me, we're going to create 2 constructors. If I get a constructor call that's empty, well, then I'm going to follow this path, use my database, and carry on as normal. So every time the controller gets created, it's going to ask itself that question. hey, did any mock data come in? If so, I'm unit testing. I don't need the database. If I didn't get any mock data handed to me, okay, well then I need the database because this application is running live. Right now, our controller, it always follows this path. It just goes from here to the database directly. So we're going to create two constructors and two different interfaces, one for mock data and one that uses the database. We're basically going to rewrite or refactor all the code in here. Now, there is a quick way. We can do this quickly for a minute just to try our little method. If we just want to know if this loads an index view, we're actually going to need to temporarily comment out most of our code here. Here's our comment this out, which now breaks this line. Let's just comment out the two lines in our index just for now. And for now, let's just return a view. That's it. This should get our unit test to pass now, right? If we run our test this way. It's going to call the index method, which will load a view, a method, return a view called index. Problem is we can't build because by disabling the database connection, all our other methods, they all use it. So now we've created a whole bunch of errors. If I try to build now, I've broken everything. Okay, so I get 48 errors doing this. So this is a case of we can't make an omelet without breaking a few eggs. Right? We're going to have to break a few things in order to put them back together. So for the moment, I'm going to comment out all my other methods. I'm going to go from here. And then as we write the unit tests, we'll put these things back one at a time. So I'm going to comment out everything, and we can just write our test one method at a time. So write down everything except my last two closing curly braces. I'm just going to comment all that stuff out. So we've broken the music store. Right now, the album index is the only thing that will run. So all of these are commented out. So right now, this is the only active method with one line of code. So now we can build, and we'll try and run our unit test again. Okay, interesting. So we expected index, but our view name is actually empty. Interesting. So this is not the right property we want to check. Here's where our debugger is handy. I'm going to run my unit test again, and we can inspect our result. We might have to obviously refer to some different kind of property because the name of the view is showing up over here as empty. So this time I'm going to debug my test. It'll run it again. So it calls our index method. So here's my result, is a view result. But interestingly, view name is empty. So here we'll be able to check the view bag. But we're going to need something else. The view name, in this case, isn't coming back. The reason is In the MVC world, if we just return a view, it automatically gives it the same name as the method. Our unit tests aren't aware of this feature. So in order to fix this, we're actually going to specify the name. Being explicit about it, this should make our unit test pass. So inside my controller method, we're explicitly saying the name that's returning is index. And now our unit test passes. So we're probably going to need to refactor our return statements to explicitly state the name of the view that's coming back. Our application works without this, but our unit tests don't. And it's probably a good idea to be very explicit about what names of the views we're returning. So this unit test will pass now. But now we got to deal with the more complicated part, which is working with the data. So we've taken the database out. So now we need to do a bunch of stuff to replace it. So the first thing we need to do is we need to create two interfaces here. One that connects to the database and one that just mocks up albums when we're unit testing. So we're going to make our mock one first. So inside of my models, I'm going to add a new item. And under code, I'm going to pick interface. So I'm going to call this one I albums. I'll call it iAlbums mock to be more clear. So this is for working with fake data when we're not connecting to the database. I'll make it public. So we're going to set up everything we need in here to mock the create, read, update, and delete method. These methods don't actually do anything. They don't work with the database. So we'll have a public property called albums that will be a list of albums. So we're going to call this in our index method. This is instead of querying the database, we'll just create a fake list. We'll see. We can start there. We'll have a fake save method where we pass in an album with a fake delete method. Pass in an album. When we're unit testing, we're just going to call these things. Call our fake list, call our fake save, call our fake delete. We're probably also going to have to add a list of genres and a list of artists here. Because when we look at our album model, every album has a parent artist and parent genre. So we're probably going to need to include these in our mock as well. We can try it without, but I think it will fail without those references. So this is our mock interface. Now we're going to create, so we've created this mock repository. Now we need to create a repository for when our application's actually running that talks to the database. I'm going to add a class. This one I'll call EF for entity framework. So this one actually talks to the database. I'll just call it EF albums. And it's just a class. So this class is going to be based on that interface. You guys have probably worked with interfaces in Java before. So I'm imagining it's not a new concept. So it inherits from our albums mock. Now it's saying, okay, well, if this class inherits from that interface, then it needs to have a list of albums, a save, and a delete method. So we'll let Visual Studio, if I just say implement, it now implements the interface. It gives us a list, and it gives me delete and save methods. Close up Test Explorer for now. So in here, our database connection is now going to go in here. We've taken the connection out of the controller and we've put it in here instead. So now for our list of albums, we use the database here. Our get method will return db.albums. So our query that gets the list of albums from the database, it's now moved here. It's come out of our controller. Remember, we're adding this layer in between our controller and our database. So that's, we're creating this file here. Delete. We take an album in. So now we just call db.albums.remove. Save. Any deletion now happens here. Doesn't happen directly in your controller. And save, in our scaffold controllers, we have separate methods for creating and updating. Our one save method can do both. We'll just evaluate if we have an ID or not when we're saving a new album. If we have an ID, we'll do an update. If we don't have an ID, we'll do an insert. In this case, if we have an ID, we're just going to mark the state of the object as modified. So here we're creating a new object. Here we're just modifying an existing. So we can do insert and update in one method now. So both our create and edit will call this interface. We'll call this one method in our repository. So our code for interacting with the database is actually a lot smaller now. A lot of this stuff was kind of repeated in the scaffolded controller. So we have two different versions of this repository. Our EF one that talks to the database, and our mock one that is in memory only. There's no database component here at all. And so these are just kind of pretend versions of this. So we've set up two repositories, one for mock data, one for working with the database. I'll just build and make sure we're okay. So now we'll need to go back to our controller and write the code to handle the dependency injection. How do we know which repository we want to use? When are we working with mock data, and when do we want to connect to the database? So in our albums controller, we're going to create two constructors. So we've commented out the database connection. So this time we're going to use our DB, but now it's actually referring to our interface. So now we need two constructors. When nothing is passed into this controller, so if nothing's passed, we're going to use the database. This is our default option. Most of the time, we want this controller to connect to the database. Here's our second constructor. So if we pass an object of mock albums, we're unit testing. So don't connect to the database in this case. We don't want the database connection when we're unit testing. So now we should be able to rewrite our code. And though we've taken out the order by and the including, let's just see if this now gives us a list of albums again. We may have to add our artists and genres to our repository. Now remember, our albums are private, so we need to log in admin account. I'm going to see if my albums index still loads now that we've refactored the code. Based on the time it's taking, I think it's safe to say we're going to get an error. Oh, okay. So notice our page, now that we've refactored it, it still connects to the database and gives us our list of albums. Although our sorting is gone. So we want to put that sorting back into our query. So we want to add this same copied my order by and then by. So we've successfully refactored it. But because we've moved database connection out of our controller, we should be able to unit test the controller now. If this ever finishes loading. So now we're back to sorting alphabetically. So our database connection is no longer being called from inside the controller. So we can instantiate this controller. So let's check our unit test. Now, can we actually still run our unit test? I'll just right click and run the test. Okay. It still fails. Any idea why? Let's see. It calls index. Remember, we have two constructors. Which one of these constructors, or I guess I should do it this way. So which version is being called and why? We wrote two constructors, one that's empty and one that takes a mock object. Yeah, the empty one is being called. And we can see this version got called, which uses our database. Next to the database. We've set up our controller properly, but it's still using the database. So that's still going to fail when we're unit testing. We need to call the other constructor. But in order to call this constructor, we've got to pass in a mock object here, which we haven't done yet. So down here in our unit test project, click on Tools, NuGet Package Manager, and Manage NuGet Packages. If you click on Browse over here, this will let us search NuGet Central Repository. What we want is a package called mock, the most popular and friendly mocking framework for .NET. Over 38 million downloads. I'm going to click on it. Last updated a couple months ago. And we want to install it in the unit test project. We don't need it in the web application. We need it in our test project. So just check off the name of your project name of your solution .tests. That will install this framework. Okay, I'll say yes to this warning, and I accept. Okay, so it's installed mock. Close that window. So now what we need to do in our test class is we need to set up some mock data. So when we call our index method, we're passing that mock data. So the first thing we're going to do up here is make a reference. Now we're going to use this mock object on all of our methods, but for now we'll just put it inside this one test, and then we can make it global in this whole class, so all the unit tests can use that one mock object. So this would be underneath the arrange. We're no longer going to call the empty constructor, because when we call the empty constructor, it connects to the database. So we want to set up some mock data and then pass that mock data in the constructor. This is in the model namespace, this repository. So we need to make a reference to the models. Right? We have no access to that interface. So we just add a reference to the models. So we're going to set up some mock data. We're going to make a fake list of albums. And again, their unit test doesn't even know what a list is. So it's prompting me, make a reference to system.collections.generic. Lists are known in .NET MVC, our unit tests are not familiar with the .NET list. So we'll add this reference. So we're going to create 3 fake albums. I'll make 3 fake albums. We'll make each one a different price. So again, we're going to want this same mock data in all our test methods. So we'll move this to a global method. We don't have to repeat it over and over again. Now we'll just put it right in here. Now we want to populate our interface. Mock data. This mock library has a setup method we need to invoke. So again, I need to add one more reference here. We want to be able to query that list of albums. We need to reference the link library. So I'll just add this reference. So now the last thing we do in our constructor is we pass it the mock object. Because when we pass nothing to the constructor, the controller connects to the database. When we inject a dependency, we say the controller takes in or needs this mock object. It doesn't use our database. We're passing in this list of data in our mock. This should finally allow our unit test to pass. I know it was a lot of setup, but we can use this whole block of code. We're going to move it out of this test method in a minute because we're going to want to do this for every single unit test. If we try and run this unit test now, hopefully we won't get a database connection error because this is no longer going to connect to our unit test. Okay, well, we got a different error. So that's good. I think we just have a bit of a syntax problem. So our object's not set to an instance of an object, but it did not try to connect to the database. Well, we'll just run this with a breakpoint and see where this, how far this got and where it dies. So it set up our mock, right? Here's our list. Our count is 3. So far we're okay. Right? We've got albums 100, 200, 300. So now we're passing this. So notice this time it calls the second constructor. Takes in our object with 3 albums. Now it calls the index method. Okay. So we're getting an error here. This is because of our artist name is missing. We're trying to sort by artist name, but we didn't include an artist name in our test data. So we're almost there. So it's getting almost all the way here. So we are going to need a fake an artist property inside. So we'll go back to our mock. We'll add artists. And then we also need to add an artist name into our 3 mock albums. Because if we want to sort by that property, it has to exist. We have no artist name property right now in our fake data set. So we'll add an artist here. And then every album has an artist property. Close this up. I'll make up 3 artists. So now each album will include an artist object. This should prevent it from crashing when we try to sort by artist name. Okay. We changed our mock interface, but our albums doesn't have it. We need to add this when we're using our database as well. So now we'll run our tests. So after all of that, there's a lot of lifting. Our unit test, to get one unit test to pass. So it's a good news, bad news scenario. The bad news is that setting that up is a ton of work. The good news is writing most of the other unit tests will actually be simple. So the last thing we should be able to do now, we can move, all of this stuff is global. So even here, our entire arrange, we can actually move to a test initialize method, and that method is automatically called before every unit test. So we don't have to repeat this stuff. So we'll do two more things. It'll take us 5 minutes. We're going to create that test initialize and move this code. And then we should be able to write the other index unit test that, who was it who had index? Gave us the unit test. Was it you guys? Right? We still want to be able to check. So we know it's loading the right view. We also now want to make sure it returns a list of artists, a list of albums. So up here, if I put in a decorator test initialize, so this is going to run before all of our unit tests. So basically the arrange is going to mostly happen in test initialize rather than happening in every individual method. So a few of these things we're going to declare globally. I'm going to declare this object because we're going to use it everywhere. So that stuff can go. There's our mock. And our list of albums. We'll declare these things globally. Then I can just take out this here. So now all of this code from where we instantiate the mock right down to when we instantiate the controller, let's move all of that to initialize because we need this code to run on every unit test. So we can take it out of this individual method and plunk it in there. Whoops, I guess this declaration, I'll take out albums controller here and I'll declare it up here because again, it's global. So we have three global variables: the mock object, the list of albums, and the controller we're testing. And then initialize creates the mock object, populates it with data, and calls that constructor with dependency injection. So if we run the unit test now, it should still pass because test initialize gets invoked automatically with this annotation. I think we can just run this test again with our refactored code. Test still passes. We don't actually need any arrange at all. We can just act and assert. Check our code coverage right now, it'll be really good, which is because we commented out all the methods in the controller. So our code coverage, I imagine, should be 50%. It returns the view called index. We've checked that, but we haven't checked the data that's coming from it. We could just do a quick analysis. So let's see in the albums controller where we at. Okay, so we're at 87%. It actually says index is fully covered. But really, we are short a unit test because we're not actually checking the data. We're only checking that it loaded the right page, but we haven't actually checked that we got the right data. So we should probably write one more test for that, and then we'll call it a day. Sure. So 3 things declared: the mock, the list, and the controller. So we should be able to write a unit test with just 2 lines to actually check that we've got album data when we call the index method. So we'll write one more test method. So let's call it index returns albums. Right? The method we're calling and what we actually expect to get back. So in this case, what we expect to get back is a list of albums. We're going to call the index method. But what we want is we want to get the model, right? Because our index returns a list of artists. That's the model in our index view. Oh, oops. Sorry, I just missed the bracket. We're calling our index. We get back a view result, and then we're taking the model. And we're casting that as a list of albums. So what we expect to get back is our list of fake albums from up here. We set up the list of fake albums. We call the index view. We should get the same list back. We'll just run the test. Well, that's interesting. Says they're not equal, but we did get the same type. Oh, when we're comparing lists, we use collection assert instead of assert. Assert are equal checks two individual objects or values. These are lists. So our view is albums. Okay, I'm going to have to think on this one. It says our two elements don't match. I'm not sure why. We're passing in a list. Okay, I will set you free. I'll figure out this unit test and we'll start here next week. So we will have a quiz to start next week's class. All about unit testing. Oh, it's not working because our method sorts them. We set them up in order by ID, and our index method is sorting them based on artist name. So I've got to resort my mock data based on artist name, and then they'll be equal. We'll do that next week.